Hello, dear students. Glad to meet you again in this session. Now, in this session 1.3, we are going to see about measurements of matter in the same chapter, some basic concepts of chemistry in grade 11. Before getting into today's session, let us recall what are all the topics that we have discussed in the previous sessions. In session 1, we have discussed about importance of chemistry and nature of matter and its classification. In session 1.2, we have discussed the 7 basic units of the SI system, its symbols, and the name of the SI units and the symbol of the SI units. Learning outcomes. At the end of this session, students, you will be able to define mass, weight, volume, density, and temperature. Conversion of units of temperature and its derivation. We all know that anything that occupies space and has mass is called a matter. What is mass? Mass of a substance is the amount of matter present in it. What is weight then? Let us see what is mass and what is weight now. Mass and weight. Mass of a substance is the amount of matter present in that substance, whereas weight is the force exerted by gravity on an object. Mass of a substance is constant, whereas its weight may vary from one place to another. Let us consider a situation. When we place an object like this on earth and find out its mass, and if we place that same object on moon and find out its mass, will it be same? Yes, the mass will be same in both the cases, because mass is nothing but the amount of matter present in that object. But when you see the weight is the measure of the gravitational pull on an object. So assume in case A, the pull of gravity is x units, and in place B, the pull of gravity is 2x unit. Obviously, the pull of gravity is greater in place B. The mass of the object is m in both the cases, but the weight of the object is greater in place B because the pull of gravity is stronger. As the gravity is twice in place B, the weight of the object is also twice in place B as compared to place A. So, mass of a substance is constant, whereas its weight may vary from one place to another. Mass of a substance can be determined very accurately in the laboratory by using this analytical balance. We know that the SI system of mass is kilogram, and we know the conversion 1 kilogram is equal to 1000 grams. In laboratories, we use very small amount of chemical, so we need to express mass in grams. Volume. Volume is the amount of space occupied by the substance. Look at this box. Volume is the space that the body occupies. What is the unit of volume? Its unit is length cube. Why length cube? Why this cube they have given? Because it has length, breadth and height. So its unit is length cube. What is the unit of length? We all know that the unit of length is meter. So the unit of volume is meter cube. Here you could see a cubic unit, right? It has 1 centimeter length, 1 centimeter breadth and 1 centimeter height. So the unit of volume is meter cube. Smaller volumes we are using in the laboratory. So we have to denote the volumes in cm cube or dm cube in laboratories. Some volume measuring devices for solutions. These are some volume measuring devices for solutions in the chemical lab. They are burette, pipette, graduated cylinder and volumetric flask. Generally, we express the volume of solution in liters, but liter is not an SI unit. So, whenever we come across the word liter in chemical calculations, we have to convert it into 1000 ml. We know the conversion 1 liter is equal to 1000 ml. In laboratory, small amount of chemical solutions are used. So, these small volumes are expressed or denoted in cm cube or dm cube. Look at these two pictures of forest. Here in picture 1, we could see more trees. In picture 2, we could see less trees. So we use the word dense. This forest is more dense when compared to this forest. Now let us see the definition for density. Density of a substance is its amount of mass per unit volume. Let us see the definition of density with an example. Density of a substance is its amount of mass per unit volume. Per unit volume is nothing but space in 3 dimension. So when you put a wooden log on river water, what would happen? It will float. Why? Because wooden log has less density when compared to the density of water in the river. That is, mass present in unit volume of the log is less when compared to the mass present in unit volume of river water. So at the same time, when you put a rock piece into the same river water, what would happen? It would sink. Why? Because the mass present in unit volume of rock piece is greater when compared to the mass present in the unit volume of river water. So, density of a substance is its amount of mass per unit volume. Hence, we define density is equal to mass per unit volume. So, SI unit of density can be obtained as follows. SI unit of density equal to SI unit of mass upon SI unit of volume. What is the SI unit of mass? Kilogram. Yeah, what is the SI unit of volume? Meter cube. So, kg upon meter cube. When this meter cube in the denominator comes to the numerator, we have to write plus 3 as minus 3. So, SI unit of density equal to kgm minus cube. In laboratories, the unit of density is denoted in gram centimeter minus cube, where mass is expressed in grams, not in kilograms, and volume is expressed in centimeter minus cube. Next one is temperature. The 3 common scales to measure temperature are centigrade, Fahrenheit, and Kelvin. Among these 3, Kelvin is the SI unit. The thermometer with Celsius scales are calibrated from 0 to 100 degrees centigrade, where these two temperatures are the freezing point and boiling point of water. The Fahrenheit scale is represented between 32 to 212 degree Fahrenheit. Negative temperatures are not possible in Kelvin scale. Relationship between the units of temperature. The units of temperature are related to each other. Let us consider 3 identical glass apparatus of equal volume and size. If we assume one of the apparatus shows the Celsius scale, the next one shows the Fahrenheit scale, and the last one shows the Kelvin scale. When we keep all these 3 glass apparatus in a trough of boiling water, what would happen? The mercury starts to expand and reaches the upper fixed point, which is same in all the 3 apparatus. In Kelvin scale, it reaches 373 K. In Fahrenheit scale, it reaches 212 degree Fahrenheit. In Celsius, it reaches 100 degrees centigrade. Now, let us keep all these 3 apparatus in an ice tub. Now, the mercury begins to contract and touches the lower fixed point. It touches 273 K in Kelvin scale, 32 degree Fahrenheit in Fahrenheit scale, and 0 degree centigrade in Celsius scale. Now look at the distance between the upper fixed point and lower fixed point. It is same in all the three apparatus. So let us mark it as capital L. If we keep all these three glass apparatus now in a tub of hot water, not boiling water, the temperature of the hot water will be in between the boiling point and the melting point. Now the mercury starts to expand to certain level which is equal to the temperature of the hot water, and this level will be same in all the three glass apparatus. And let us mark the upper point C in Celsius, F in Fahrenheit, and K in Kelvin scale. When you notice the level of this upper point and the lower point is also same in all the three apparatus. So let us mark it as X. Since the level of L and X is same in all the three apparatus, let us equate the L by X ratio in all the three apparatus. Since we have taken the same amount of mercury in all the three apparatus, the distance, that is the level of L and X, also same in all the three apparatus. So we can equate the L by X ratio like this. L by X for Celsius is 100 minus 0 upon C minus 0. C stands for Celsius, right? Then 212 minus 32 upon F minus 32 for Fahrenheit, and 373 minus 273 upon K minus 273. Now let us equate these Celsius and Fahrenheit. Let us consider these two L by X ratio. Now 100 minus 0 upon C minus 0 is equal to 212 minus 32 upon F minus 32. Now 100 minus 0 is 100 divided by C minus 0 is C, which is equal to 212 minus 32 is 180 divided by F minus 32. So now we can cross 100 by 5 and 180 by 9. Now when we cross multiply these equation, we get 5 by 9 into F minus 32 equal to C, which is the relationship between Celsius and the Fahrenheit units of temperature. Now let us see the relationship between Celsius and the Kelvin scale temperature. For this, let us equate L by X ratio of Celsius and L by X ratio of Kelvin. 100 minus 0 upon C minus 0 is equal to this 373 minus 273 upon K minus 273. 100 minus 0 is 100 upon C minus 0 is C, which is equal to 373 minus 273 is 100 upon K minus 273. So we can cross this 100 and this 100 by 1. Now when we cross multiply these equation, we get C plus 273 is K. This is the relationship between Celsius and the Kelvin scale. Conversion of Kelvin to Celsius temperature. Already we have seen this temperature versus pressure variation graph in the previous session by taking two test element gas, and when we extend these two curves, it meet at a point minus 273.15 degrees centigrade, which is the absolute zero temperature, and this absolute zero temperature is 0 K. When we move from Kelvin to Celsius, we need to add 273.15 K. Students, now let's recall what we have discussed in this session. We have discussed the definition of mass, weight, volume, density, and temperature. And we have discussed the difference between mass and weight, and different units of temperature and the conversion of units of temperature we have discussed in this session. Hope this session is also very useful to you. See you soon in the next session. Thank you.